It's not finished. This is the basic idea. It's really simple. It just says blockchain. Make it bigger? Yeah, thank you.
Awesome. Super awesome.
Okay. It just says, in the profile, there will be a key called blockchain ID. It'll have a version. Here are the keys. Notice there's pub and private. Yes, that actually is the private key. This is an optional use of blockchain ID. You can use blockchain ID to have a user password experience completely decentralized, like just completely decentralized. You can, in other words, have software. You can use a strong password to generate a public-private key pair, like Minilock does, and store the private key in the blockchain encrypted with like scrypt plus AES. And then what does that allow you to do? That allows you to effectively go on, like, you don't have to store the private key on your computer, in other words. So you can go on your phone and you can have a password manager that enters your username and password, and it can ask the blockchain, what's my private key for signing a message? Retrieve the encrypted thing, decrypt it with your password, and then sign a message, which is really cool. It results in the same user experience that people are currently used to. For the more paranoid ones, because that would result in these brute forceable keys on the blockchain, for the more paranoid ones, you don't have to specify the private key, you can just store it locally. So in the specification we say that private is optional. We talk about the kind of user experience thing that it does. Endorsements are, that's what it was called, it was endorsements, not affirmations. You can make public statements. So let me give you a neat little usage of this that I've heard from a friend. Imagine you're going to the New York Times and somebody makes a comment. You don't know who that person is. But there's a little badge there that says, oh, this person is from your church. This person is from your meetup group. This person attended Blockchain University. It kind of gives context to people in online conversations. And those statements can be made cryptographically secure using a system like this, which is, I think, kind of nifty. And you can also make such statements privately. So it's also possible to, for example, have a secret group such that when somebody comments on a website, only the group members of that group see that that person is a member of that group. That's another possible application of this. You can also use it, universities could use it to make a statement like, this guy actually got a diploma, and we really signed this diploma. I mean, there's a lot of fraud going on with people inventing diplomas. This can be used to solve that problem. All kinds of other problems. And DNSChain itself, here is the GitHub. I'm currently showing the Mocha branch, which is one of the ones that is far ahead of master. We've got, oh geez, I've got to fix that. Let me see if I can show you what that's supposed to look like. We've got tests. So this thing is actually being tested on Travis to verify that it's functioning correctly. Here's what that table is supposed to look like. And it talks about the advantages of DNSChain. The disadvantage, the main one, is, again, real ownership, that you can actually lose something. Because if you lose a domain, or if somebody else has registered your domain, you can go, hey, I have the trademark for this domain, give us the domain, something along those lines, or, etc. So that's an advantage, and that's why I actually think it's a good idea for these two systems to live alongside each other. You can certainly imagine some websites that would prefer to have their domains in the blockchain rather than on ICANN. Yeah. So then we have a comparisons document. And you can reach that from the README, the alternatives, and also we have a, oh wait, it's in the Mocha branch. Right here, see also how DNSChain compares to other approaches. we have this whole docs folder with how to set up DNSChain, how to use DNSChain, how to set up DNSChain with Power DNS, Namecoin on a server on a Debian machine. When we link to other documentation. But my favorite piece of documentation is the comparisons page. We put, I spent a lot of time studying other systems and going through them. So there's a Google certificate transparency effort. And we explain why it doesn't solve the man-in-the-middle attacks and why it doesn't even detect all of them as it claims that it does. There's DNSSec. DNSSec, yeah, you can read about it. There's convergence. There's also TAC and HPKP. Firefox recently added a feature called HPKP, which is just the concept of pinning a website's fingerprint, SSL fingerprint. That has usability problems because we enumerate them. First of all, it's TOFU, which is trust on first use. It doesn't protect users who visited the website for the first time. It breaks websites when their public keys need to legitimately change. In the case of TAC, there's another issue. And then another problem is that all of these systems assume that the client software, this is kind of like a really big one, client software has its current time set properly because they all depend on expiry dates. Like this pin is valid for such and such a time period. Well, what happens if the client's clock is screwed up? Then they're not going to be able to visit the website. They're going to get a warning or an error message. You don't have that problem with the blockchain because all you care about is what is the public key at this current point in time. And DNSChain uses a one pin to rule them all approach. So what you do is, right here, what you do is, a priori, the DNSChain server, completely forgot. Why are we even talking about DNSChain? Why don't you just use a Namecoin node? The reason is because Namecoin nodes cannot be reasonably expected to be run on laptops or mobile devices because they have to be connected to the network 24/7 to have the most recent information, and they use up a whole bunch of resources. So DNSChain establishes a man-in-the-middle proof channel by using pinning. So you know what the fingerprint is supposed to be. You set it, and there are ways of improving that we're working on. As far as in terms of usability. That's the one time that you have to verify a fingerprint. After that, no other secure chat messaging app do you need to verify fingerprints anymore if they're using the blockchain. So it's just one little pin and that's it. And then
could you just use like
thin clients?
Thin client.
So that's in our documentation as well. Thin clients. We just recently updated it to add some discussion on thin clients, and we think thin clients are really great. Because they allow you to access blockchain data in an extremely efficient and lightweight manner. And the new approaches are sometimes referred to as SPV+, or Ultimate Blockchain Compression for Unspent Transaction Outputs, UTXO, give you security that's, if not equivalent, nearly equivalent to a full node. But there are still problems with thin clients. First one is their non-existence. There's no thin client out there that does SPV for these arbitrary key value data stores. And there's not going to be one for some time because they're very difficult to implement. Over-reliance on SPV clients can lead to a centralization of the entire network because there are fewer full nodes running out there. So DNSChain actually incentivizes people to run full nodes, which is good. It keeps the network decentralized and healthy. If all the SPV clients are just talking to a couple full nodes, and that actually might be more of a realistic possibility than you might think when we get in terms of high transaction volume and the scalability problems that you guys might have covered in this class. That means that fewer people will be able to run full nodes. Some platforms don't support thin clients very well, like iOS. On iOS, you cannot have a server running in the background that other software talks to. That's not approved. That's not an Apple server that Apple has specifically allowed. That's for battery life reasons and things of that sort. So in that case, you would need a thin client with every single application that wants these features, that wants this security. And supposing you did that anyway, you still have the problem from a user experience where mobile devices are offline frequently, and they get out of sync with the network. So the users will have to wait, that means, for the thin client to synchronize back up, pull the latest headers from the blockchain. And then every single request to a new website has to do all of this extra overhead work of looking at the Merkle tree, pulling the correct transactions and all of that stuff. So that makes connection, that adds latency to every connection. There's latency when you have to synchronize back up with the network. In other words, you want people to visit a website for like probably several seconds, depending on how long you've been offline and how long it takes to retrieve all of the transactions and verify that they're correct. With DNSChain, with like a framework, an app that uses a framework that lets it talk to DNSChain via an API, it's instant. You just say, what's the fingerprint? And over that connection, you don't need to wait. You just instantly get the fingerprint, the correct one. Okay, so one more thing. We're about to release a major update to DNSChain. It's going to include a lot of new features. It's going to include, let me see here if I have one. Yeah, this is the feature list for DNSChain 0.5 coming out apparently a few days ago. Is that?
I'm going to finish the last one.
Okay. So we're actually we added support for retrieving ICANN information, traditional DNS over HTTP or HTTPS via a RESTful interface. We added the next support for the next blockchain. Maybe we'll get, depending on what the one-name guys, maybe we'll even add support for the block store, either this release or the next one. We added traffic throttling to protect from DNS amplification attacks and to protect your server from people who are abusing the RESTful API. We added Redis caching for both DNS requests and HTTP RESTful requests. We added full HTTPS support. We're working on also censorship circumvention through unblock, where you use the DNSChain server as a proxy. And that's a whole other conversation. So we did a lot on very little funds. By the way, you guys should donate, help us out, or just help us with the code. That would be also awesome. Add your name to this list of contributors, and as far as a RESTful API goes. Let me show you what API is coming. We've got this thing coming soon. This is really cool. So there are a lot of companies whose sole business model is offering a RESTful API to the blockchain. While that's great, we're not super thrilled with that because that's like, a step backwards in our opinion. The blockchain is about decentralization. When you add a company that's offering a centralized, easy-to-use point for resolving information on the blockchain, you oftentimes, depending on how they implement it, have to completely trust what they say. And that's having a central point of failure as well, another central point of hacking. We don't like that approach. We want people to, if they want, run their own DNSChain server or trust a friend's, or when thin clients come out, use DNSChain as kind of a middleware to thin clients so that locally they can use this API, this one RESTful API, to build applications, secure that email that behaves just like regular email, but is fully end-to-end encrypted and doesn't rely on untrusted third parties. iMessages, etc. All of these different secure messaging applications. You can start building applications that just use a very simple RESTful API. You can see that it has, the version number, the blockchain, the resource, the property that you're looking up. So this is ID/Bob, URL encoded. So yeah, resource, property, operation. So like here, we have an example of an operation, transfer, optional arguments, what address we're about to transfer something. Initially, we're only going to have support for reading from blockchains. In the future, we'd like to add support for writing to blockchains as well. And you can do that in a way that doesn't trust the DNSChain server by holding the private keys locally and just signing messages and sending them to the DNSChain server to then send to the blockchain to distribute to the rest of the network. I think that it's 12:23 right now. I think this is a good stopping point, and now I welcome your questions. Yeah?
There's one disadvantage of doing stuff on the blockchain, which is like you can lose stuff that you mentioned. You mentioned that one disadvantage, right, relative to other schemes.
Can you speak up a little bit?
You said there was one disadvantage with storing stuff on the blockchain was that you could lose stuff, right? When you were comparing
Oh, right, yeah, I forgot to mention that. Let's go back to blockchain ID. So notice these, so there are two keys, in other words, two key pairs. There's one key pair that you're using on a daily basis to sign messages and to verify other people's messages. These keys are stored in the blockchain. And then there's another key pair, you can think of it almost as a backup or emergency key pair, for actually updating the information that's in the blockchain. So say you lose the public-private key pair, or it gets hacked or something. This one, these two, or this one and the one that's like stored locally. You can simply then use the other key pair for updating the entry in the blockchain, and just switch these out, update them to something else, generate a new one. Yeah.
But I guess what you were referring to is that the other one that you code as a backup, that's signing.
Yeah, that one can be lost, and then you're like, then you need to rely on some of those other methods that we talked about, like multi-sig, shared secret sharing.
Right. Yeah, so I was actually going to ask about the secret sharing. Is there a secret sharing based scheme that has tried to address this problem? Because the thing with DNS as it is today is it tells you who you need to trust. With secret sharing, you can decide who you are going to trust, right? And so I think that even though there's some transfer of trust involved, that's a better.
Yeah, so the comment is that with DNS today, it tells you who you need to trust, or with X509, it tells you who you need to trust. Whereas with secret sharing schemes, you get to decide who you want to trust with your identity, with your bitcoins, etc. And yeah, we think that's a better world.
So all these things, they seem to imply control of the namespace, where there's no central authority that controls that namespace. But for things like, for the real world where you might have, trademark law or other socially mediated kind of mechanisms for talking about how we name things, are there mechanisms, like, it seems like all of these things are based on the first come, first serve. Like if you take a name and you have the private key for that, then that's what prevents anybody else from coming in and taking that name. But it doesn't represent any sort of social process that name is recognized by anybody else. So I don't know if you guys have put any thought into that.
Okay, so let me see if I understand what you're saying correctly. Basically that a lot of these blockchains are first come, first serve as far as name registration is concerned. And the concern, can you be more clear?
And that there's no social process for overriding that.
And there's no social process for overriding that, right?
Yeah, and so I'm just wondering if there's been any thought put into, can you have...
Yeah, that's a good question. Actually, I think, well, first of all, okay, as far as first come, first serve goes, there has been thought to addressing that. People have implemented, like BitShares DNS had a bidding system for registering names, where there was a period of time where you could bid on names. Blockstore, my understanding is that the rules for each namespace define what's required. Like they can even specify the price of particular names. I think they were looking into that. I don't know if they actually implemented it, but like based on the name length, for example, the shorter ones come at a higher price, etc. The person who owns the namespace can specify what the rules of that namespace are. That reminds me, earlier on I was talking about malware, or there was a conversation about malware. You can protect against malware by storing the hash of binaries in the blockchain, and when you download the binaries, verify over a man-in-the-middle proof connection the hash of that binary. That's another huge potential opportunity for a use case for blockchains to verify updates of software and make sure that they haven't been tampered with. And actually, but to finish answering your question, as far as a social mechanism for restoring names to their rightful owners, I don't think enough thought has been put into this, and that's something that people should be thinking about more. You can imagine, of course, like there could be a legal system. If you know who registered a domain name, you can compel somebody to hand over their private keys through the legal system.
or sufficiently distributed multi-sig type thing where.
Right, and you can imagine coming up with a way where, like, your ownership depends on several other people agreeing that you own a thing. You can imagine people establishing organizations to sort of reinvent ICANN on top of the blockchain, where ICANN has part of the private key or has the private key and everybody trusts them to be honest. So you can reinvent the current system on top of the blockchain, but you can also not. Yeah, that you can do both. I think you had a question.
Yeah, my question was similar. All of these blockchain distributed, whatever, name registration systems have one thing in common. How do you stop the first guy from grabbing every desirable name, A through Z, 2A through 2Z?
Right, well that's usually financial.
A through triple Z, and so on.
Yeah, so how do you stop people from name squatting? It's a very important problem, question, and the way that people address it is by putting a cost, just like in traditional squatting problems. People will squat on traditional domains all the time, and there's a cost to registering each one of those domains. What's nifty about Blockstore is that they allow individuals to register a namespace and then allow the individual to decide what the rules for that namespace will be. So I think that's really cool, and I think that can go a long way to addressing that problem, because you can have some highly desirable namespaces that, for like businesses, where the cost of registration is high. Somebody really wants this domain, they will pay a good amount of Bitcoin or whatever the currency is for it. And then you can implement bidding systems on top of it, where the initial registration goes through a bidding war for a certain period of time. A lot of innovation can be done there, and these are all awesome projects that you guys can work on. Yes?
Yeah, the hard part is if you require bidding for every name, then it's slow, and it also leads to leaving names high and dry. A really complete solution, you'd have to kind of have an auction for each name, not just that, but it would expire, and there'd have to be a market for each name, because if you require bidding and a high price for everybody, you're going to massively overvalue all the names, but massively undervalue a few desirable names at the time.
Right.
So it's not an easy problem to solve.
Yeah, it's not an easy problem, and there are multiple approaches to solving it, and it might turn out to be kind of an evolutionary thing where we will find out after the fact what the best approach is by seeing how these different namespaces, how popular they are, and what people's reactions to them are. Are they able to get the name that they want? Are they unhappy about squatters, etc.?
The cool thing is you'll have the statistics on how involved, which we don't have with the current namespace, like how they got consumed and changed in value.
Right, yeah, so the comment was that it's neat with the blockchain that all of this is kind of public information, and so we can, after the fact, analyze the data and see which namespaces blew up, which namespaces, et cetera. We can figure out what a good approach to solving name squatting is.
So I think you have to ask my question. So for doing the secret sharing to mitigate this one disadvantage, is there any support needed in the blockchain or DNSChain, or it's just a user's implementation choice?
For doing so, the question is, for doing secret sharing, is there